So I would like to welcome our next speaker, Alexandru Bolboaca. He's a polyglot programmer, a trainer, and a coach at Mozaic Works. He has worked for almost 20 years in software development for various industries and various European countries and in the UK. And his third book, Hands-on Functional Programming in C++, has recently been published. He's going to talk about surgical refactoring of non-tested code today, a worked example. And if you have any questions during his talk, please use the stage Q&A to ask them. So, Alex, the stage is yours.
Thank you so much. I'm Alex Bolboaca. I am coming to you from the Mozaic Works studios from Bucharest, Romania. I am vaccinated, I am caffeinated, and I am ready to talk about one of the topics that interests me the most, and that is how to deal with legacy code. And in particular, one definition that I think about when I think about legacy code is how to deal with code that is not tested, or even more with code that I am afraid to change. This is one of the main challenges that I think we are having, and what I'm going to show you today is a method that I thought about that I believe improves the way we deal with legacy code. And I have to say this method has been inspired by a lot of other methods that are around and by a number of people, particularly organizers of legacy code retreats and of course, Michael Feathers, who wrote the book on working effectively with legacy code. And so what I have today is a method for surgical refactoring of non-tested C++ code. The examples will be in C++, but the method itself works in any language. I've used this in Java, I use this in C#. There are a few differences and I will try to discuss them, but I think it's best for you to tell me at the Q&A whether you have any questions about your specific technology and how it can be applied there. A quick note about my slides. My slides are not actually slides, they are a video, and I will skip through it a few times because it's a bit longer than the allocated time. But you can, I posted in the chat the link so you can watch it later at your own pace. All right. So what am I trying to do with this method? What I'm trying to do is to have a repeatable way of dealing with legacy code that is also more effective than the methods that we have, the methods that were defined by Michael Feathers and by other people. And just a moment. And so this method uses the idea of pure functions, and I will define pure functions as functions that return the same output when they receive the same input. This is not a fully correct definition in terms of functional programming, because in functional programming, it's also that it's immutable. I don't care if there's mutation inside the function, but I do care if there's mutation going outside of the function. And the procedure that I will show you is to use pure functions to make dependencies explicit and testing easy. How do we do that? First, we separate pure functions and input-output functions. There are two different categories from the rest of the code. We write data-driven tests or property-based tests for the pure functions, and finally, we regroup the pure functions into classes. Now, I have to say this is a surgical approach, so it doesn't mean that you have to take your whole base and turn it into completely into pure functions and then turn all the pure functions into classes, because that will never work. Instead, you pick one area of the code and you apply this approach there. And what I have is an example in C++, as I said. We use the compiler and the refactoring tools to ensure correctness, so we don't write tests in the first part of this method. And so we select a piece of code, the extract method, either automatical or manual. In C++, we can make everything constant. In Java, it's a bit more challenging to make things constant. You need to pay more attention. But you can make the function static in Java or in C#, and then you figure out which are the dependencies, because the method will tell you, the compiler will tell you which are the dependencies for that function. And then you inject those dependencies. So let's see a quick example. I'm using the trivia code base that's used for exercises on legacy code. And the first thing is I select a piece of code, and it can be any part of the code. I extract it as a method. And then I try to make it, as I said, to restrict as much its mutability and to restrict as much its dependencies. So I want ideally to make it static and const. And already when I extracted in CLion the method, you can see that it has some issues because it is const, but it already tells me something is changing inside of this method. And what is changing is that the collection of pop questions there is actually modifying. So I need to make it non-const for a while, and then do some more work on trying to make it, to get it closer to purity, right? We are trying to refine this code and to separate the pure parts from the impure parts. And you can see I'm writing a few comments. That part is pure, it just creates a string. The other part is impure, it changes the pop question collections. So how do we deal with that? We try to make it again pure. And we try to extract actually the pure part and separate it from the impure part. Now we also notice something else, that the output of this method is actually a string. So the input is the string pop questions and I. What this code does actually is combines pop question with a number. So it will write pop question 1, pop question 2, and so on. And so I can introduce even some more things into the pure part, because oss.str, that's fundamentally toString of the concatenation between the pop question and the I variable that is pure. So now I can extract this part, and this is the pure part. With a bit of simplification, the CLion refactoring doesn't work as well as in Java or in C#, for example. And now I have a pure function. The next thing is to remove any kind of dependencies for this function. How do I do this? I try to make it static. And the compiler tells me already, look, you have a dependency. You have a dependency here that tells you that I need to inject some things. And once I can figure this out, I can move this function. Now, once again, in C++, this refactoring move function is a bit more complicated than in other programming languages. In Java, it's quite easy to do that. Fundamentally, what I'm trying to do is to create a place where I move all the pure functions that I'm creating for now, just temporarily. And so I need to create a file. I will call it pure functions, obviously, and need some changes in the compilation and so on. And at the end, what I am doing is to move this function there, include everything that's required. As I said, this is much easier in Java. In IDEs for Java will just move the function very easily. Now, if you're doing this in Java, of course, you cannot use this free function approach here. Instead, you'll have a class that has only static methods. And ideally, that also use final, or, well, that don't change the input parameters. All right, so this is the general approach for the first part. And just dealing with a few more things and committing things often. Of course, I like to commit very often. I'm running the code from time to time just to make sure that the code still runs, but I am not checking the actual result. I'm actually pretty certain that by using this approach very precisely, you can avoid changing the behavior of the code, because all I am doing is extracting methods, making things constant, moving methods, and taking advantage of the compiler. All right, so we have now already a pure, in this constructor, we have some impure part, pop question.pushback, that adds a new question to a collection. So that is not pure. But the other part, the create part, is actually pure. So this is what we've done until now. We turned the function into pure function. We managed to do that. How? By restricting first the change of input values inside the function, and then by surfacing the dependencies of that function. Now, the next step, once we have pure functions, we can take advantage of something that's very nice, of data-driven tests or of property-based tests. I only show the data-driven tests approach here, which is fundamentally a table of values that says, for these inputs, I expect these outputs. In C++, what we have is not the nicest approach, but if you are using something like Spock in Java or in Groovy, then you will actually have tables that you can write and write this test as a set of inputs and outputs. So now I can write these tests, and these tests are incredibly simple to write because I'm just counting on, this is the input, this is the output I'm expecting. And please notice that there are a few weird values here. It's -1, -65, 535. There's also, again, 65, 535. There's 0. These are values that are not actually, let's say, used inside this program, if you look at the original code. But I like to write these tests anyway, because what I'm showing is what the function is currently doing, not what I would like it to do, or not what I would expect it to do. So now you can write these types of tests fairly easily. And we end up, after a few changes, with a few very simple tests that check. So in this case, I had to implement a few custom asserts and so on. If your unit testing library allows for data-driven tests, it's usually much easier than this. Okay. So now we can do the same things for repeat for other types of tests. And now that we have tested all these functions, we can see that there's a common pattern emerging. We have create pop question, create science question, create sports question, and so on. So perhaps there is some duplication there. And since I have tests, now is the time that I can remove this duplication by replacing all these four methods with a single method that uses the correct, well, just some input values. And these will be tested because I have tests for all of those, so I can go in small steps and test these things easily. And it is a simple way of simplifying the code, fundamentally. This is what I'm looking for in the end with this approach. I'm not looking just for a way to reshuffle the code, but also to simplify it. But we have to simplify it at the right moment, and this means, of course, first have tests and then change behavior of the code. Don't try to change the behavior of the code before, except for those very strict changes that we've seen in the first step. Okay, so now we are running the tests and we can see that things are going fine. And now the next question is, do we need to separate these somehow? Do we need a questions class, perhaps? And that is a design decision that you will make depending on your own ideas related to design. And I'm creating here a questions file where I will move everything that's related to questions, just to simplify for now what is happening. Another interesting thing that's happening here is that we've extracted in the meantime some of the input-output functions, and the difference between the pure functions and the input-output is that the input-output functions actually have some, they change something, they change either the output or the read from the input. And I'd like to make them specific. I'd like to make them very clear that they are doing this. Right? And so I make these changes. I'm moving everything to a questions class. Well, to a questions file for now. It's not yet clear what will be in that class or if this will be a class at the end. And so what do we have here? We have ask questions, we have print next question, we have update questions. And these are things that emerge. So for example, the update questions is something that takes from a list of questions one question and returns the remaining of the list, because I wanted to make it again immutable. It's not performant, it's less performant than it used to be, but it is now immutable. So I can actually test it and move it easier into its own class. Now, the interesting thing, if we have these functions that are pure, it means they receive all the necessary dependencies as parameters. They don't change the context. They don't change the input values. They only return an output value. And I can regroup them in any way I want. I can move them to any kind of class I want. This is one of the very powerful things about this method, that the pure functions are actually kind of like a nominal way of making design. Not in the sense that it's the best way to design software, but in the sense that it's the one that provides you with the most options once you have reached to pure functions. You can group pure functions in any way you see fit into classes. And so this will be the next question is, okay, let's group this into classes. And how I'm doing this, small steps, because again, in C++, it's a bit more difficult to refactor this kind of code. We need to go little by little and first create a class, create an empty constructor for that class, and then move one by one the functions inside that class and make sure that we change all the calls and make sure that we also update the tests in the meantime. So this is what's happening here, little by little, moving things inside the class. And you can see some tests are now not compiling. These are limitations of automated refactoring in C++, in C Lion. Again, in Java or in C#, it's a bit easier. There are also some things that I need to do here, like some functions become private. I have some tests for those private functions. I leave those tests for a while, or I delete some of those tests, because some of these tests are actually checking the same things. And I'm trying to move these functions into the class and turn this into a class that actually has proper encapsulation and hides the members that should be private. Moving some more methods inside the questions class. And now we can separate this into four for loops, which again is not the most effective way of doing things, but all I care for now is just to improve the design and to add the tests and to improve the design, at least for now. And then I can improve performance if I really need to. Often at the end of this refactoring process, you end up with code that is actually more performant than you would expect, but sometimes you need to make a few more changes. So now we have create, little by little it starts to emerge another function which creates multiple questions. Because as you could see, we have another type of duplication. First, we had the duplication that we are creating categories of questions like pop question 1, rock question 1, sport question 1, and so on. But now we also have another type of duplication, which is we are creating 100 questions of each category. And that is another type of duplication that I can deal with right now. Now I have to change a few things here in order for this to work in the tests, but we can skip a little bit more. And we will see that by repeating this process for other question types, we end up with code that should pass all the tests. And we have 167 assertions that are checked. We have a pure functions test file that tests all these pure functions. And we have created a few additional helpers for my tests. In this case, I needed a separate check method or a third method for the collections that I'm dealing with right here. And again, little by little, we inline a bit more of these things. And we try to do more, we try to simplify the code little by little and kind of get it at the same, make the duplication explicit, change the duplicated code, remove some of it. While we also have this under test, okay? So it's time to look at the other types of questions. Things start to repeat here between the different types of questions. We can have these questions. So we have question, we have questions, perhaps in the questions class where we move this creation for a number of questions instead of just one type of question. And once again, this happened little by first extracting pure functions, then writing the tests. Everything is tested, and now we can move those functions into their own classes and group them based on cohesion, based on those pure functions that actually fit together and that actually work together. We also wrote a bunch of, well, a lot of tests here, as you can see. Now, there are some issues with test separation. I'm skipping some of these things that are not as interesting to show. But I have the whole videos recorded, so this whole session recorded and commented, so that if you want, you can see even in more detail. We have it in one of our learning programs on refactoring. Okay. So let's look at the tests for a moment. We have duplication between the tests as well. So it might be an idea to remove some of this duplication. And of course, there's always a question when to do this. I prefer to have first tests that check everything and then look at how to improve the test design. And I kind of go between the actual refactoring of the code and the refactoring of the tests. Now, there are a few specific things that can appear. There are situations where you have, it's more difficult to do the change in towards pure functions. And you don't see all the types here, but there's always a way out. There's always a way to, based on what I've seen, there's always a way to separate the pure part from the impure part. Now, as I said here, we are refactoring these tests because I don't want to have everything, to have such long tests, and especially not to have them with duplication. And if you have the proper the proper asserts offered by your unit testing library, then it's easier. Here I'm actually writing some of these asserts just so that they work, that I know they work. And again, the important part here is I want to have custom asserts or checks in this case. I usually don't like to repeat the body of the test to remove the duplication from the test body, but I like to remove the duplication from the checks, from the asserts. And soon we'll end up with very fast checks that allow me to write tests and to deal with tests in a much easier way than until now. And that is the main goal here. So now we are extracting yet another one of those create functions, and we can, as you can see, we can now write very easily a new test for the new function. Given that we remove the duplication between tests, is now much easier to do that. So this is one of the techniques that allows us to, particularly when we have so duplication in the code and data-driven tests for various functions, you can then remove the duplication between the tests, and it's much easier to write tests for any similar functions. Since everything is now under tests, we can now deal with the creation of these questions and simplify a lot what is going on there, right? Now let me just quickly skip to a few other things. What is important now, one question that I often get is, how do you move pure functions into a class? And first we move it little by little, but more importantly than that, what we are trying to do is to figure out which are the functions that are cohesive, the functions that fit together. And how do we know that? First, we can know from the names of the functions in case we name them properly, because they will keep repeating some parts of the name. We can also know by the parameters. And in case we have the same parameters for more functions, then perhaps they need to be together in one place. And this is how I know. And then I try to move them together little by little. And we will see soon that now we have a questions class that receives a prefix, pop question, science question, and so on. And then you call create questions on it, and that creates all the questions that we had until now. I have to say that we are getting close to the end of this codecast. But what is interesting is that you can apply the same approach for all the other parts of the code. Just take one bit of a code and little by little make the code pure, introduce classes, write data-driven tests, introduce classes, introduce objects. And you end up with code that is restructured in a way that you like, but in a very safe manner, if you are following the steps very precisely. So now we have pop questions, objects, science question. I'm just naming them, giving them some names. And of course, I will rename them afterwards in a way that's nicer. And once we do a bit more refactorings, we end up with this questions class that has a prefix, a create question that's private, a create as public, current question that returns the current question, and the next question. And this is how it's used. We have a question list by category and the question printer that are separate objects. And so what this means is that we've introduced actually, we've separated the dependency. We did out the dependencies, and We have objects that are separate, that make sense. And instead of having one big thing that does a lot of things, we have smaller objects that are specialized and that can do the things that are important and that are also tested. Now, of course, the end design can differ based on your preferences. I'm not trying to impose this on you, but it just shows how you can refactor this little by little through this method. What I like about this method is that compared to Michael Feder's method of refactoring legacy code, in that case, you need first to write characterization tests and only then to refactor, and often the start is very difficult, while here the start is very easy. You pick an area of the code without the pure from the impure part, write the tests, and then you can regroup it. I'd like to thank you for watching, and in case you are interested in learning more about this method, I will post a link in the chat towards our learning program. And in case you are interested in listening to interesting conversations with people from software development, we have a YouTube channel where I have such conversations with people. And now I'd be happy to answer your questions.
Thank you so much, Alex. Right now, we don't really have any questions. So if you have questions, please use the stage Q&A to ask them. And until we are waiting for them, I would like to thank you with this mug, with your image on it. It looks really cool, and also it has the Craft logo. So thank you so much for the presentation. And I'm checking again the Q&A. So we are going to share Alex's presentation, so you can rewatch it if you missed something.
Yeah, thank you so much for the mug.
It looks and check out his YouTube channel and continue this conversation. Thank you so much, Alex.